and welcome to today's Machine Design Quick Chat. I'm Bob Vavra, Senior Content Director for Machine Design. Today, we're going to be talking with Klaus Thum, the Product Director at Altec, and we're going to be discussing the value of dual-rated AC-DC disconnect switches. Klaus, thanks for joining us. Give us a little bit of your background before we get started here today.
Yeah, hey, good morning, Bob. Thanks for having me. I am obviously from Germany. That's why I have the accent. I am an electrical engineer, studied in Germany. Before my studies, I also was a journeyman electrician. So I have some practical background, and then obviously some theoretical background. And I have been with Altec now for about 25 years. First as a product manager, and now as a product director. So I don't know. Do you want to know anything else?
No, that's a great place to start, because you've got, as you said, both the practical side and the product side of this. So let's talk about, from both of those aspects, what's first of all the purpose of a power disconnect? What do we get out of it?
So if you see any kind of a machine, you usually see a disconnect on it. It usually has a yellow-red handle, but then you also see the yellow and red e-stop push button on it as well. So obviously an e-stop push button is for an emergency. That push button is usually rated at maximum of like 10 amp. So if a user or any kind of machine, runner, or however you want to call it, in an emergency presses that push button, the push button usually controls the coil of a contactor, which then that contactor drops out the power to the whole system and disconnects, obviously, in case, as I said, of an emergency. So, but with an e-stop, you have these different steps in there, where in rare cases there could be some failure, meaning the auxiliary switch doesn't work, meaning the coil doesn't work, meaning the coil can't activate the contactor. So you can see you have some built-in problems possibly there. So with the power disconnect, you alleviate all that, and you go you're right in series with the power circuit, and you switch that disconnect. You disconnect, and you are sure that you're disconnecting the power. So it's really more of a, how should I say it, a backup power service disconnect versus even an untrained user of that machine would usually just hit the e-stop in case of any kind of an emergency. So with a power disconnect, you have more of a controlled shut-off to isolate the circuit.
And safety with electrical is always the paramount goal in all of this. So as you said, the skill set of a lot of the workers that are exposed to those kinds of electrical systems vary, and being able to have a system that's really safe fundamentally, even beyond just the e-stop, is really the goal of this.
Yes, correct. And even just for maintenance or any kind of a service for the equipment, you want to make sure the power is off. Obviously, nobody wants to get electrocuted. Nobody wants to have any kind of injury or God forbid anything worse than that. And also nowadays nobody wants to get sued about things like that. So the power disconnect is really your main means of making sure really everything, all the power is isolated from the panel or the equipment the user works on, or the maintenance person works on.
I've experienced an arc flash event standing behind 18 inches of solid glass, and you could still feel the explosion coming, the waves of the explosion coming through the glass. So we know the power and the danger of such things. So as we look at this, the AC DC disconnect switches, why are we looking at a new design?
That's a good question, Bob. It's always like competition makes us better, right? So competition drives us to be better. So there's definitely some sort of a competitive pressure here. And the competitor had a smaller disconnect. And by the way, we never mentioned here, we are really talking about a small disconnect here, up to 40 amp in this case. So it's a smaller disconnect. For ease of installation, our manufacturer in Finland designed it to be modular in a way that terminals can be installed in the front or in the rear of the whole switch. So the whole switch can be ultimately like mirrored front to back. And then that helps a lot for certain installations where I will get into details a little bit down the road here. And then also, these are usually DIN rail mountable, but some people still prefer panel mount. And for that, we don't need any additional accessory or any kind of a short DIN rail or any kind of a contraption. So the panel mount tabs are integrated into the design as well. So there was one of the aspects of, why is there a new design? The other aspect is we have quite a big customer who had certain requirements on a new switch, so to speak. The smaller footprint, as I mentioned already, but then in addition, how should I call it, like a modular design, meaning usually a power disconnect is built around the three-phase system out of Europe. But here in the US, you might have a single-phase system where you have just two hot legs, or you might have only a one-pole requirement because you want to just switch off, because we are talking about an AC-DC switch here. You want to just switch off one phase or one pole because maybe of a DC circuit. And so now with this new modular design, we can do 1, 2, 3, and 4 pole in any kind of a configuration. In addition, we have an add-on auxiliary switch, which has various terminal configuration to mirror the front and back terminals, and in addition, also a quick connect terminal. And we can also integrate that auxiliary switch right from the factory into the main switch. In addition, scalability. You want to make sure your production is scaled so you can up to however many pieces you want to run at a certain amount of shift. So the production is completely automated. And it can be scaled up to running 24/7 really if necessary. And then one of the other thing is the DC rating. As I mentioned before, we are talking about an AC-DC disconnect here. A built-in DC rating, which is really these power disconnects come from the AC field. So the DC was never in the old days an issue, but nowadays with more and more applications coming in the DC field, electrical vehicle chargers, robots, any kind of just to start with some applications, battery packs. It's really important that you have a DC rating as well, because customers just want to stock one part number. They don't want to say, oh, I have my AC version and then I have my DC version. They want to have one part number, and that can do it all. Then on top of it, we are just coming out of a pretty, or maybe we don't even really didn't come out yet of a pretty tough time with the COVID pandemic. Now conflicts, international conflicts all over the world, tension rising. You want to make sure, your supply chain is secure. You want to make sure you can get the materials, right now at a reasonable amount of lead time, and you can sustain all these materials. You can sustain the availability of these materials. Because, for example, I'll give you an example. We had one switch, which is, how should I say it, a little bit more of a rare of a plastic. And all of a sudden, through the COVID pandemic, the prices spiked, and then there was no availability. So we were like, okay, we cannot produce this switch anymore right now, or the lead time is a year, and that is really not serving anybody well. So with this switch now, we made sure we have alternative materials in the UL file. We have, the plastic is more common and readily available everywhere from various suppliers and manufacturers, and so on and so on. So, but now I rambled for a while, Bob. Why don't you say something?
No, but those are all good points, because it's not always about what you want to do from a safety standpoint. It's what's available for you to do from a safety standpoint. And this really is a nice intersection of great technology and then thinking through the supply chain part and the availability of it to make sure that customers have what they need when they're asking for it. You mentioned one other thing that earlier on that I wanted to go back to, and that's the flexibility on the installation standpoint. Can you talk about some of the different ways that the AC/DC disconnect switch gets installed, either, as you said, on the DIN rail or in the cabinet?
We here at Audec, we get a lot of calls about what parts do I need for what application, and I think it really is all based on people using different terminology for the same thing, and that's where it gets confusing. So we have, as I mentioned earlier, we have two different versions of this switch. One where the terminals face front towards the front, and one where the terminals face towards the back. The version where the terminals face towards the front is made to be used in the door interlock application. We call this the LSF switch. When you have a 508A panel, or you're building a 508A panel, whoever is a panel builder is familiar with it. The back plate of the panel unscrews, and you can take that out of the panel, and you can lay it on your workbench, and then you install all your components either on the DIN rail or direct panel mount onto that back panel. After you're done with all the installations of your components and all the wiring, you can set that whole back plate back into the panel. So the purpose of this back plate is that you don't have to be inside the panel and maybe hunch over or kneel down or things like that to install certain components. So it makes the installation much easier. But we are not talking about 508A panels and how to install them. We are talking about the switch itself. So, but the switch can either be mounted then on the DIN rail on the back plate of the panel, or it can be panel mount. Then to connect that whole mechanism to the door so to speak, you need to use a shaft. The shaft needs to be cut depending on the depth of your panel, and then you have to follow our installation guidelines on how to cut the shaft, how to cut the end, and what length to cut the shaft to. And then you obviously also have to make sure you install the door interlock handle on the outside of the door in line with that shaft to make sure that that interconnects. So the three components, the door interlock handle on the outside, the shaft, and then the back panel mounted LSF switch need to interlock and interconnect with each other. And you have to make sure everything is lined up. And when you do that, then you have, so to speak, the main power disconnect of your UL508A panel installed. And that also enables you then usually to make sure you can only open the panel door when the power is off, because that's where the phrase interlock comes in. If the handle on the outside is in the on position, and obviously then the switch is in the on position and the power is on, you cannot open the door because the handle and the shaft interlock the panel door. So you can only open the door when the power is off, the switch and the handle are in the off position, and that's when you open the door. So for the door interlock application, you need the switch mounted to the back plate of the panel, either by DIN rail or by direct mounting. You need the shaft and you need a door interlock handle on the outside of the door. Then we have another application, and we use the term door mount for this. So door mount, I was just talking about a door mounted door interlock handle. Now I'm talking door mount application. So really, that's maybe why a little bit of this terminology confusion, is sort of based on really this door mount switch, which now we call it, it's the RT switch. It's really more used for side panel mount installations, where you have maybe some sub downstream circuits which control maybe part of the panel, and you want to have an easy way of accessing these sub circuits from the outside of the panel, but you don't need to shut the whole panel power off with these door mount or side panel mount switches. So with this, and really from user input over the years, and again competitive pressure from some of the competitors, our manufacturer Cutco made the switch, as I mentioned earlier, in the modular fashion to have these door mount versions or side panel mount versions have the terminals facing towards the rear or towards the side, or however you want to look at it, to make sure when the switch is installed, then you have access still to the terminals, and you can easily install then your wires to it, and it's a very simple. You drill a hole, you install the handle. It's almost like installing a 22.5 millimeter push button into your front panel or side panel or wherever. You have a handle and you have a mounting nut. You screw that together. The handle and the mounting nuts are hold onto the door or to the side panel. And then all you do, you click in with a little spring-loaded clip, the RT switch from the back, and then you install your wire. So ultimately, you have two part numbers. with a total of 3 pieces of equipment to install, where some of the competition, might have a door mount kit, so to speak, where there are 27 parts, where a washer and a screw and a bracket and a shaft and all of that is in this kit. You lose one of these components, you have to buy the whole kit again. So here it's as easy as it gets, as easy as installing, as I said, a 22.5 millimeter push button into the front or side panel, and really Cutco thought of everything when they designed the switch. We really have high hopes of selling a lot of them, and we thank you. We thank Machine Design for this platform here to maybe just talk about it on a more leisurely, in a leisurely format. So thank you very much.
Thank you, Klaus. A lot of great information. We talked about ease of use. We talked about the availability from a supply chain standpoint, the importance of electrical in all of our manufacturing operations today. And of course, at the outset, we talk about safety. So those are all very important things. If you're looking for more information, you can go to www.alltechcorp.com for more information on this. I want to thank Klaus Thum, the product director at Alltech. I'm Bob Vavra, senior content director for Machine Design. Have a great rest of your day. And as always, stay safe out there.